Hello, Midnight Coders, and welcome. So, Java has spent decades earning two types of reputations. Once it's warmed up, it is one of the fastest platforms on the planet. But getting there, okay, that is a whole other story. Okay, so what if Java could remember everything that it learned from the last time it ran? What if your application could skip thousands of expensive startup operations and just get straight to the work? Well, for over 25 years, Java has been accused of being slow. Slow to start, slow to warm up, too heavy for the cloud. And according to the OpenJDK team, the primary goals of Project Leyden are, are to improve the startup time, the time to peak performance, and the memory footprint of the Java applications. These issues make their impact with cloud computing, containers, Kubernetes, serverless platforms, microservices, basically any application that has to continuously or constantly start, stop, and the latency matters the most, especially the more that you did in the age of long-running monoliths. So, why does Java even have this problem? Well, Java was designed and optimized for maximum runtime of the application, not the startup speed. So a typical startup would launch the JVM, hundreds of thousands of class files are read. Their classes are then verified, linked, metadata is optimized, bytecode is interpreted, profiling information is gathered, the JIT compiles hot methods, and then we finally hit peak performance. So the JVM eventually becomes lightning fast. However, that performance comes after seconds or sometimes even minutes of warm up. So the team behind Project Leyden asked, how much of this work can we safely do before the application starts? Okay, so let's talk a little bit about the history here. So back in 2018, throughout 2020, Java's popularity in cloud-native services exposed a weakness. Containers frequently restart. This is commonly caused by hotfixing a microservice or scaling up horizontally. Serverless functions needed instant startup. Hundreds of microservices launched hundreds of JVMs. Meanwhile, other languages like Go, Rust, .NET, even GraalVM were demonstrating dramatically faster startup times. So the OpenJDK community began discussing ways that they could modernize Hotspot without abandoning Java's dynamic nature. So in 2020, the initial decision, Mark Reinhold had proposed Project Leyden to the OpenJDK mailing lists. One of the important clarification that was made immediately was that Project Leyden would not simply merge GraalVM Native Image into the OpenJDK. Instead, it would build on existing JVM technologies, including Hotspot, CDS, JLink, and AOT computing technologies, while preserving Java's compatibility as much as possible. So now we roll up to 2022. Project Leyden begins. So when Mark published the design note, which effectively became the philosophy the philosophical foundation for Leiden, he described the project's goals as solving a slow startup, slow warm up, and a large memory footprint. So initially, the proposal talked about static runtime images, kind of like native images, and the OpenJDK team quickly recognized that this would break many of the current frameworks. So rather than force Java into fully static model, they began moving towards a more incremental approach. So now, in the early days, people heard Leiden and assumed, oh, Java native images. Instead, the project is a lot more interesting. They're not emulating the JVM. The JVM itself becomes smarter by remembering previous executions. Now, instead of making Java less dynamic, it moves the expensive work more earlier than whenever possible. So some of the major milestones here, and I'm going to cover this quickly, would be the JDK 24 with JEP 483, the ahead of time class loading and linking, JDK 25 with JEP 415. This was the ahead of time command line ergonomics. JEP also inside of the JDK 25 is JEP 515, which was the ahead of time method profiling. Next comes JDK 26, where we see JEP 516, ahead of time object caching. Okay, so what is missing from this list? One major piece remains under active development. This is ahead of time code completion. So this is likely the feature that most people associate with true ahead of time. So instead of waiting for the JIT compilation, compiling all the machine code could already exist before startup. This is still listed as in progress by the Project Leyden team, and the goal isn't necessarily to beat native code, it's to dramatically reduce Java's startup overhead while keeping Hotspot's long-term optimization advantages. Why in the hell should developers even care about Project Leyden? Project Leyden is one of the biggest architectural shifts in the JVM, and it's a huge undertaking. Okay, so instead of introducing a single revolutionary feature, we'll say, it incrementally rethinks how the JVM starts applications by moving the expensive work from the runtime directly into what we call training time. Um, and the result is a faster startup and a shorter warm up with even lower memory overhead and better performance in cloud native environments. All while retaining the mature hotspot JVM that Java developers already rely on. So, in short, what does all this mean? Well, Project Leyden isn't about making Java native. It's about making the JVM remember what it was that last happened. So by shifting the expensive startup work ahead of time, Java applications launch faster, they reach peak performance sooner, and they consume less memory, all while keeping the compatibility and dynamic features that made the JVM successful in the first place. So if you enjoyed this video, hit that subscribe button. For more, smash that like button so that other developers can find the video. And as always, keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you in the next one, guys. Check out this video here, somewhere. YouTube thinks you'll like it. Somewhere here.